The video presentation by Nguyen from the University of Adelaide, Australia, presenting on the title Redesigning an Anticoccidial Drug for Treatment of Multidrug Resistant Bacterial Infections.
Good morning, everyone. My name is Nguyen. I'm the PhD candidate at the University of Adelaide, Australia. Today, I'm really happy to share a part of my PhD project about redesigning an anticoccidial drug for the treatment of the multi-drug resistant bacterial infections. First of all, I would like to introduce the background of the project and also the reason why. Antibiotic resistance is a global issue. It's the cause of the 10 million people may die. That's what estimate by 2050, and the death is higher than that caused by the cancer and the diabetes. And we also need to spend up 100 trillion US dollar if the issue will not address well. Gram-positive bacteria is cause of the high mortality and the morbidity. Therefore, a lot of the drug has been developed for the treatment of gram-positive. However, for the gram-negative bacterial infections, there's only few drugs available for treatment of the gram-negative infections. Because the gram-negative bacteria contain the outer membrane, that prevent a lot of the antibiotic to kill them. At the moment, polymyxin is considered as a last-line drug for the treatment of the gram-negative bacteria because the drug target is out of the membrane. However, the issue is polymyxin is very toxic. It's toxic to the brain, to the kidney, and to the muscle. Therefore, the no dose of the polymyxin can be used in combination with other conventional or the novel antibiotic is considered as a new treasury for the future treatment of the gram-negative infection because of the three reasons. The small amount of the polymyxin in the combination will perturb the outer membrane of gram-negative to allow a lot of the antibiotic to work. And also the small amount of the polymyxin in the combination will reduce the toxicity level of the polymyxins. And also like the combination drug in showing the synergistic activity to avoid the resistance. My project is going to find a solution for the treatment of the gram-negative bacterial infection and also like propose the solution for gram-positive infection as well. Here I would like to introduce one of the novel antibiotic I found, that is called NCL195. NCL195 was redesigned from NCL812. And NCL812 is an anticoccidial drug. That is a drug using for long and used a lot in the poultry and the rabbit production. And as you can see in here, NCL195 contains the pyrimidine score and NCL812 contains the guanidine score. By changing the chemical structure, NCL195 showing the better activity and less toxic compared to the NCL812. So it's really interesting result in terms of the redesigning the structure of the drug. Our primary data indicate that NCL195 destroys the membrane potential of the gram-positive. However, it didn't destroy the membrane potential of the gram-negative when it's using alone. However, when NCL195 combined with the polymyxin or the colistin, in here, in this graph is with the colistin, it's showing that the combination destroys the membrane potential of the gram-negative. So based on this data, we hypothesize that NC195 alone will not show the activity against gram-negative bacteria. The reason because the outer the membrane will be prevent NC195 to get inside of the cell. That's why you can see there's no membrane potential of the gram-negative when it's using alone. However, when NC195 combined with the conistin, with a low amount of the conistin when we use in the combination, we perturb the outer membrane to have the NC195 go inside to meet the drug target just located in the inner the membrane. Now I'm going to show the evidence that we found to prove for our hypothesis. First of all, is the result of the checkerboard assay. The checkerboard assay is a method to determine the synergy activity of the 2 or 3 drugs. In here is the combination of the NC195 and the conistin combination. This is a typical example of the checkerboard assay of the NC195 and the conistin against Klebsiella pneumonia. The checkerboard assay was performed on 90 well cyclate. So yellow color well here is a contain the broth only, and this is using as the control for determine the activity of the drug. The green well here contain the NC195 alone with the corresponding concentration behind, and also blue well here is contain the conistin alone with a concentration of the conistin underneath here. And this is the area that is a combination of the NC195 and the conistin at different concentration. The activity of the NC195 and the conistin was determined using the minimum inhibitory concentrations. It calls the MIC. The activity, the interaction activity of the NC195 and the conistin was determined using the FICI. Is called as functional inhibitory concentration index. This is the formulation for calculation. And this is a graph for the interpretation of the FICI. If the FICI lower than 0.5, it means the synergistic interaction between NC195 and the conistin. If the FICI from 0.5 to 1, the interaction is additive. And the indifferent if the MICI from 1 to 4, and of course more than 4 is antagonistic. Here's the summary, the result of the activity of NC195. NC195 showing the activity against the gram-positive, and the typical example for the gram-positive is the MISA. And showing no activity against gram-negative. However, very interestingly, when it combined with the sub-inhibitory concentration of the conistin, the MIC of the NC195 back to 0.5 to 4. Why I mentioned conistin is a sub-inhibitory concentration? Because the concentration I use in the combination is lower than MIC of the conistin when using alone. And on the FICI is lower and or equal to 0.5. So it's really interesting result for the combination of the 2 drugs. Now I'm going to show you another evidence for the interaction between the NC195 and the conistin. That is this is an image of the cryo to showing the morphology of the bacteria affected by the NC195 alone, conistin alone, and combination. As I mentioned before, NC195 have activity against gram-positive bacteria, and typical example is the Staph aureus. So you can see that the membrane is broken. And NCL195 have no activity against gram-negative. So you can see in here the membrane with the treated with the NCL195 and the membrane without treatment look like exactly the same. And the cell treated with the colistin at no concentration at 0.25 mg per ml, you start to see a little bit effect. However, you can see the huge difference of the morphology in the cell treated with the combination NCL195 and the colistin. So this is the in vitro data. It really brings me a lot of interest. And then I'm going to move to the next step to test the in vivo efficacy of the NCL195 alone against gram-positive bacteria and also against negative bacteria in combination with the colistin and again gram-positive bacteria as well. In order to determine the efficacy of the NCL195, I'm using the bioluminescent mouse models in which I use the Staph aureus Science-2022 is a bioluminescent representative gram-positive bacteria, and also I use a representative gram-negative bacteria is the E. coli Science-14. First of all, I inject the bacteria into the mice following with the treatment of the antibiotic. And the mice after that will put in the black box for the light output measurement. The always corresponding with the number of the bacteria in the living mice. As you can see in here, I do the dilution of the bacteria. Increase the bacteria will be increase the light output. This model is really showing a lot of the advantages compared to the traditional method in terms of the rapid exact and real-time monitoring, and also we use a lot of the mice in the one experiment because I only need you one of the mouse in the one experiment throughout the beginning to the end. And also this model helps us to satisfy a lot of requirements for the animal ethic in terms of the refinement. Here I'm going to present the result of the oral efficacy of NCL195 against the gram-positive. Group received with the NCL195 at 50 mg per kg is showing the bacteria reduced over of the time, and it's corresponding with the light output measurement. As you can see, there is significant difference between the vehicle group and the NCL195 group. And this photon measurement also corresponding with the survival rate. As you can see, the group received with the NCL195 for hour 6 survived over 7 hours. Meanwhile, the owner of the vehicle was died after 13 hours. And now I'm going to present my data about the efficacy of NCL195 and the colistin combination against E. coli Science-14. As you can see, the group received with the colistin at no concentration. The 0.125 mg per kg, the bacteria very hot. It really is similar with the group received with the NCL195. Group received with the NFI at 50 mg per kg here, consider as a control. And the control because the NCL195 is showing no activity against gram-negative. And when I combine NCL195 and the colistin, the number of the bacteria reduced significantly. And the mice image is corresponding with the survival rate. Group received with the combination 5 out of 6 survived over 72 hours. Meanwhile, the group received the colistin alone only 1 out of 6 survived. In conclusion, I'm so happy, I'm confident to say that NCL195 demonstrates the in vitro and in vivo activity against both gram-negative and gram-positive. And NC195 is a membrane active drug. However, the drug targets have not determined yet. And NC195 will be potential alternative for the future development for specific treatment of the gram-positive infection and the treatment of the gram-negative infection in combination with the sub-inhibitory concentrations of the gonitine. And at the end, I would like to thank to my supervisor panel. I'm working in the eye care center of the University of Adelaide, it needing by principal supervisor, Professor Darren Trott, and co-supervisor David O'Conney, and Dr. Stephen Page, Dr. Stephen Kidd, and Dr. Tobin Nelson. And my research is a collaboration between the different groups from the University of Newcastle, Australia, from the University of South Australia, and also like from the Adelaide Microscopy and from the clinical lab, from the Findle Medical Center, and all the money funding for my research project, it comes from Dr. Stephen Page. He's the director of the Neocoli company. And at the end, I would like to thank to everyone for listening for my presentation today. Thank you very much.